Assalamualaikum warahmatullahi wabarakatuh. My name is Aulia. I will explain the material about uniform linear motion or ULM. Definition of uniform linear motion. Uniform linear motion is defined as the motion of an object along a straight path with a constant velocity. In this type of motion, the object does not experience any change in speed or direction, meaning that the acceleration is zero. ULM is one of the simplest forms of motion, as it involves no insource force action to alter the velocity of the object at once it is set in motion. The term uniform signifies that the motion remains consistent throughout the observed time period, while linear indicates that the object follows a straight line path. The straight trajectory is a key characteristic of ULM, distinguishing it from other types of motion, such as circular or oscillatory motion. The constancy of velocity in ULM implies that the displacement of the object is directly proportional to time, making it predictable and easy to analyze. The second, uniform linear motion is characterized by several unique features that distinguish it from other types of motion. These characteristics are derived from the fundamental principles of motion and provide a clear framework for understanding and analyzing ULM. Below are the key characteristics of ULM. First, straight line path. The trajectory of an object undergoing ULM is always a straight line. This means the object does not deviate from its path, ensuring that its motion remains linear. The straight line path simplifies calculation and graphical analysis, making ULM one of the most straightforward motion to study in physics. The second, constant constant velocity. The velocity of an object in ULM remains constant throughout the motion. There is no increase or decrease in speed, and the direction of motion does not change. Um, this uniformity is a defining feature of ULM and implies that the object displacement over equal intervals of time is always the same. The third, zero. Acceleration since the velocity is constant, the acceleration is ULM is zero. Acceleration is defined as the rate of change of velocity, and in ULM there is change in velocity. This makes ULM distinct from uniformly accelerated motion, where acceleration is present. For proportionally between distance and time. In ULM, the distance traveled by an object is strictly proportional the time elapsed. This means that if the time is double, the distance covered will also double. The proportionality relationship is expressed mathematically as where is the constant velocity. The five, graphical representation distance time. The graph of displacement versus time in ULM is a straight line with a positive slope. The slope of this line represents the object velocity. Velocity time, the graph of velocity versus time in ULM is a horizontal line, indicating that the velocity remains unchanged over time. The sixth, predictable and simple motion. ULM is highly predictable because of its constant nature. Once the velocity of an object is known, The distance it will travel over any given time can be calculated easily. This predictability makes ULM in a fundamental concept in precision and a useful tool in practical application. The seven absence of external force in an ideal ULM scenario. No external force on the object to after alter its motion. In real-world situation, however, friction and air resistance may affect the motion, using it to defy strike from the ideal ULM. Despite this, ULM serves as an important experimentation for analyzing motion in various contents, and the eighth energy consideration in ULM. The kinetic energy of the object remains constant because the velocity does not change. This another indication that not work is being done on the object to increase or decrease its speed. Um, Mathematical equation in uniform linear motion or ULM. The mathematical representation of uniform linear motion or ULM is relatively simple because of its consistent and predictable nature. The curve equation used to describe ULM is derived from the relationship between distance, velocity, and time. Uh, Below are the key equation and the explanation, basic education of ULM. The primary formula for ULM is S equals V time t, where S displacement or distance traveled by the object in meters, V is constant velocity of the object per seconds in meter per second, and t is time taken by the object to travel the distance in seconds s. This equation states that the distance covered by an object is directly proportional to its velocity and the time it moves. If the velocity or time increase, the distance travel will also increase proportionally. Variant of the equation. Depending on the situation, the formula can be enriched to find other variables. The first to calculate velocity, v divided equals s divided by t equals s divided by n. Additional concept in ULM, the first, relative motion. In scanners involving two objects moving with constant velocities, the relative motion between them can be calculated using the relative velocity formula V relative V1 to V2. The second, graphical representation. The equation of ULM can also be represented graphically. Distance time graph, a straight line with a slope equal to the velocity. The steeper the slope, the higher the velocity. Velocity time graph, a horizontal line parallel to time axis, indication that the velocity remains constant over time. At the third, the displacement V is distance. Displacement or D refers to the shortest straight line path between the starting and ending point of an object. Distance is the total length of the path traveled regardless of direction. In ULM, when the motion is in straight line and in one direction, displacement and distance are numerically the same. For example, problem A, a car moves at a constant velocity or for calculate the distance traveled by the car. Solution using the formula S equals V times T. S 20 times 10 equals 200 meter. By applying this equation and cosec one can analyze and solve problems involving ULM effectively. These mathematical representations are also foundational for understanding more advanced topics in physics, such as uniformly ocular motion and two-dimensional motion. Application of uniform linear motion or ULM in everyday life. Everyday life uniformly linear motion is not just a directional contact. It is within observable and applies in various aspects of daily life and technology. Understanding ULM helps in explaining and predicting the behavior of object in motion under specific conditions. Below are some practical applications of ULM. The first, transportation systems, highways. Um, Vehicles traveling at a constant speed on straight roads excluding ULM. For example, a car moving steadily at 60 kilometer for for house on a highway can be analyzed using the particle of ULM to calculate travel time and distance. Trains. Trains moving on straight track at a uniform speed provide a clear example of ULM. These calculations are often used in scheduling and managing train operation. The second, space exploration. Satellites and spec often moving in uniform motion during specific phases of their journey, just such as when they exit a step orbit. Understanding ULM is critical in designing the system to ensure proper navigation and positioning in space. The third, conveyor belt in factories. Conveyor belts used in the industries operate at a constant speed to transport goods efficiently. This machine can be modeled as ULM using precise timing for production process such as packing or assembly. The fourth, automated system. Many automated systems, such as acceleration or moving walkways, airports, function using the principle of ULM. The system mentioned a constant speed to ensure smooth operation and safety for user. The five, sport and recreation. In sports, athletes often practice running or swimming at a constant speed over a fixed distance to improve endurance. The motion can be analyzed as ULM to measure performance and predict completion times. The sixth, air travel. Aircraft traveling at a constant cruising speed over a long distance follow ULM principle. Pilots and air traffic controllers use this concept to calculate estimates arrival times and manage airspace. The seventh, traffic flow analysis. Traffic engineers use LLM to model and analyze the movement of vehicles on roads. By assuming uniform motion, they can estimate travel times, optimize traffic signals, and design efficient road routes. Um, the eighth, delivery system delivery companies such as courier service use the principle of ULM that estimate the delivery times. For example, when a delivery vehicle moves at a constant speed on a straight road, its motion can be predicted using ULM equation. Right, the nine, river and canal navigation, boats traveling on calm river canals constant speed demonstrate ULM. This is often used in terms or sweeping industry to estimate travel duration between destination. The 10, entertainment technology motion in amusement rides, such as gondolas or cable cars, is often designed to operate at a uniform speed to ensure safety and predictability. Why ULM in important in application, the simplicity of ULM allows for accurate calculation and prediction in the scanners. Its principles are often used the design system that rely on steady and predictable motion, such as automation, transportation, and navigation systems. Moreover, ULM serves as a fundamental concept for understanding more complex motion in physics and engineering. Uh, okay, maybe just this. Wassalamualaikum warahmatullahi wabarakatuh.